Hi friends, my YouTube channel is Vidyapeetam Joy of Learning. Now, let me start the subject electromagnetic theory. I am Nageshwari, Assistant Professor, Department of Triply. Now, let me start the subject Unit 1 Electrostatics 1. In my previous video, I started Unit 1 and I discussed entire syllabus of electromagnetic theory and I started electrostatics 1, that is Unit 1, and I discussed the first topic of sources and effects of electromagnetic fields. Now in this video I am going to discuss about the coordinate systems and one particular coordinate systems in detail. Now let me discuss coordinate systems. Here in this slide, we are going to see what is the need of coordinate systems and why we are going for coordinate systems. Coordinate systems is a reference system used to represent the locations of geographic features, imagery, and observations such as global positioning system, GPS locations within a common geographic framework. That means so, if simple, we can say this definition as a simplest way is that is, in electromagnetics, all the quantities are functions of space and time. In order to describe the spatial variations of the quantities, all the points in space must be defined using an appropriate coordinate system. So, that is the thing we are going for a coordinate system. That means, in order to describe the spatial variations, we are going for a coordinate systems. That means, the laws of electromagnetics are invariant with coordinate system. When we solve problems in electromagnetics, for example, finding electric field at a point, we desire the fields. The position is expressed in terms of coordinates. Those positions, okay, that is expressed in terms of coordinates. So, the coordinates are specified by the coordinate system. So, a coordinate system is a method for identifying the location of a point on the earth. So, we can say this coordinate system as a even simplest way is a coordinate system is a system which is used to represent a point in space. So that is why we are going for a coordinate system. Now, what are the different types of coordinate systems we are having? There are uh, two or more types of coordinate systems, but we are going to focusing only on three types of coordinate systems. The first and foremost coordinate system is a Cartesian coordinate system. So Cartesian coordinate system is a simplest and a first important coordinate system. So while going for the higher range of coordinates, so first of all we should know what is the Cartesian coordinate system. So Cartesian coordinate system is the base of all the remaining coordinate systems. So Cartesian coordinates is used to uniquely determine each point in the plane through the two numbers. That is, usually we can say that is x coordinate and y coordinate systems. So, this is the nothing but the structure of a Cartesian coordinate system. So, the Cartesian coordinate system, the coordinates are x, y, and z. So, x, y, and z are the coordinates of the Cartesian coordinate system. And one more thing, this Cartesian coordinate system are also called as rectangular coordinate system. Now, let us see the second one, The second one is cylindrical coordinate system. So, the cylindrical coordinate system. So, the cylindrical coordinate system is nothing but the three-dimensional coordinate system. So, which has the structure in the form of cylindrical shape. So, this is nothing but the structure of a cylindrical coordinate system. So, the coordinates for cylindrical coordinates are rho, phi, and z. So, rho, phi, and z are the coordinates for the cylindrical coordinate system. Now, the third one is spherical coordinate system. Now, what is spherical coordinate system? That is the spherical, a spear-like structure. So, if you want to locate any point in the spear-like structure, and if you want to find out points in that structure, then we need this spherical coordinates to solve that problem. So, this spherical means this includes balls, planets, black holes, etc., etc. That means, so like this. So, the coordinates for spherical coordinate systems are r, theta, and phi. So, in my next videos, I will explain the cylindrical coordinates and spherical coordinates. Now let us see a Cartesian coordinate system. Now, let us see the structure of this Cartesian coordinate system. Now, let us take the three axes, that is, this one is x axis and y axis and the z axis. So, z axis is vertical line and this x axis and this one is a y axis. Now, consider a point P somewhere here in the space. Now, join the line from origin to the point P and the distance is D. Now, join all the lines from X, Y, and Z to the point P. Now, at point P, the points are X, Y, and Z. So, we can calculate the distance D from origin to point P is given by D square is equal to X square plus Y square plus Z square. So, let me discuss in detail about the Cartesian coordinate in the next slide. Now, here in the slide, I am going to explain about the differential elements in the Cartesian coordinate system. Now, the differential elements we can take as a length, area, and volume. So, what is meant by differential length? What is meant by differential length, differential surface, and differential volume? How we can calculate all those we can see as shown in the diagram. So, here you can draw a rectangular shape like structure in the point P. So, in this point P, so draw a rectangular shape as like this. Now, we can say from the point P and the projected diagram is shown in the left side. So, in the left side, the rectangular shape is projected. So, now if you see the left side of this diagram, that is the x-axis, y-axis and z-axis. So, in between you have a rectangular shape as like this, as A, B, C, D, E, F, as shown in the figure as A, B, C, D, E and F. Okay. Now, here I am going to teach you what are the sides of the Cartesian coordinate system first. So, there are three sides of the Cartesian coordinate system. The first one is dx. The first one is dx. The dx is nothing but it is along the x direction. It is along the x direction. That means, so if you see this figure, so in this, the point DE and the point AB are all called as the dx, are all called as the side of a x, dx. Now the next one is dy. So dy is nothing but the direction along the y direction. That means, say for example, the point CD. The point CD is nothing but the dy side, and it is parallel to the y direction. That is why it is called as the dy side. Now the next one is Z, dz. So dz is along the z direction. That means in this diagram you can refer as EF point. This EF is parallel to the z direction. So therefore we can say this EF is nothing but the dz side. So therefore in Cartesian coordinates there are three sides. One is dx, second one is dy, and third one is dz. These are the sides. And now next one is I'm going to tell you unit vectors for Cartesian coordinate system. So unit vector. So unit vector is very very important while representing this entire because in electromagnetic fields or entirely is an vector fields. So therefore the unit vector plays an important role while solving the problems and etc etc. So now the x in the x direction, the unit vector we can say is a ax vector. In y direction, the unit vector we can say is a ay vector. And in the z direction, the unit vector we can say is the az direction. Now, so I discussed about the sides and I discussed about the unit vectors. Now comes the important point is differential elements. So differential elements, I repeat, there are three differential elements we are going to observe from this coordinate system. The first one is differential length, second one is differential surface, and the third one is differential volume. So now how we can find out the differential length? It is very simple. Now, if you draw a diagram, draw a line from the point P to point Q in this diagram, so we can find out the distance between these two. That is nothing but x plus dx, comma y plus dy, comma z plus dz. Now, let me discuss the in detail about the elements in the next slide. Now, in this slide, I'm going to discuss about the differential elements. So, the continuation of the previous diagram. So, you viewers, you please remember the previous diagram, and now we will see one by one of the elements. The first one is differential element. Differential length. So I told you in the previous slide itself, the differential length is given by x plus dx, y plus dy, and z plus dz minus that point xyz. So if you calculate this, then you will get dl is equal to dx into x vector, dy into ay vector, and dz into az vector. So this is nothing but the differential length of the Cartesian coordinate system. Now comes the second element, that is differential surface. Now as you know already, the surface is nothing but the area, a differential area, that is differential surface or differential area element can be defined. So it is defined in terms of surface. You know that the surface of a rectangle is nothing but the a into b, we can say simply. So therefore here we are having the three dimensions, that is one is along the x direction, second one is along the y direction, and third one is along the z direction. So therefore here we are having the three differential surface formula. Now how we can write the differential surface formula? That is, so note down this diagram. So in this diagram, ax vector, that is this ax vector is along the x direction. So here in this diagram, x will change. This ax vector, x is changing, and the remaining coordinates, that is and the remaining side y and z is a constant. Here the varying side, the changeable side is x direction, whereas the the x is perpendicular to dy and dz. Once again, I repeat, this x vector is perpendicular to the ay and also the az direction. So, therefore, we can write the ds in x direction as formula ds is equal to dy dz into ax vector. Similarly, we can write for ay vector and az vector. So, viewers, you can guess what is the formula for ay vector and what is the formula for az vector. The formula for ay vector is given by, see here in the second diagram, we can say ay vector, that is in along the y direction, this y is changing, whereas x and z is a constant. That means this y is perpendicular to the x direction and as well as the y z direction. So therefore we can conclude that ds is equal to dx dz into ay vector. Now the third formula. In the third formula, it is about the az direction. So in the az direction, here the z is a changeable one, whereas the x and y is a constant. So therefore we can write the formula as ds is equal to dx dy into az vector. So this is about the differential surface. Now comes the differential volume. As you already know what is volume. Volume is nothing but all the combination of three sides. So therefore, as I told you already, so this is dy, there are three sides dx, dy and dz. So therefore, the combination of all the three sides given together is a volume. That is, the differential volume is given by the formula dx, dy and dz. Now, let me conclude the Cartesian coordinate system. Yes, Cartesian coordinate system. So, whatever we discussed, just we conclude from the beginning. So, in Cartesian coordinate system, the coordinates are x, y, and z. The second point is the sides are dx, dy, and dz. Now, there are three differential elements. The first one is differential length. So, the differential length is given by the formula dl is equal to dx into x vector, dy into ay vector plus dz into az vector. Now, the second one is differential surface. The differential surface formula is given by, there are three differential surfaces. One is along the x direction, second one is along the ay direction, and third one is along the az direction. So, therefore, the three formulas are dy dz into x vector, dx dz into ay vector, and dx dy into az vector. And the last one is differential volume. So the differential volume is nothing but the combination of all the three sides, that is nothing but dx, dy and dz. So that is about your Cartesian coordinate systems. Thank you all.